now I'm supposed to talk about distributed systems. Does anyone have an idea of what distributed systems are? Like, have you heard of it before? You can just signify. Want to please signify so that I know how technical to take it and how not. Okay, so just very few. Um, okay. So before we start, I just want to give like a little story as to why I'm giving this talk today and now. Um, it all started on a very interesting morning. That morning, I just gave my resignation letter to the company I was working at. I was like, "Hi, I know that I said they were going to do this for longer, but it's just been 3 months, and I know that I I don't want to do this again with you guys. I mean, that was my first ML engineering role, and I was like, just 3 months. I mean, everybody's dying to get jobs, and I'm like 3 months in. I know they do it again. So I gave my resignation letter that morning, and everyone like, Bumi, please stay. And I was like, no, no, no. I think I have something. I think that I'm not supposed to be here, right? And I have bigger dreams that I don't think this company is going to do for me. So after giving my resignation letter, I was scrolling through LinkedIn. And the next thing I like, so you start looking for a job. You don't job seeker like this. So and somebody just entered my DM and was like, "Hi Bumi, I came across your article on hyperparameter optimization, and I think that we are currently doing this in our company. When you see some messages, you just know that these people they know what they are doing. Not all these people that say, "Hi, we're working for a project. I'm looking for ML engineer." Just go straight to the problem, and I knew that yes, this is for me. I mean, few minutes ago, I just dropped my resignation letter, and just some hours, yeah, and somebody reached me, and so that was how I got into the company. For my interview, just can you do this? Yes, I can. Talk, finish. And that was how I got introduced to distributed systems. I know I've read about DAX, I've read about Kubernetes. I didn't like it, like all those software engineering things. And yeah, so now what happened was this: the company wanted to, they were running models, yeah, not your typical LLMs. These very complex statistical, you have to be a mad guru, genius, do all those things. And so what my job was is basically come here, help us parallelize this, right? How can we leverage multiple computers to make this thing faster? So let me give you an idea. To run a single model takes like 6 hours. Imagine you need to run 12 models. That would take how many weeks? So now that's the background to why I got into this real system and why I'm giving this talk now. So I already said I'm a machine learning engineer. Some of you probably already know. And funny enough, I'm interested in AI policy and economics. And yes, I did computer science. I like to participate in hackathons. So not cybersecurity hacker or wejo. I'm also a community advocate. I'm a poet. I like to write poems and photographer. Thank you. So now, what went wrong? Why do we need distributed systems? Just like I said, you have lots of things, lots of tasks. You have a single CPU or four nodes or whatever nodes, but you have a single computer. And how can you efficiently like run these tasks, right? Make sure you're using like almost 100% CPU, right? And then you're being efficient. So that's where the idea of distributed systems came in. Probably some of you that have seen the movies where you have like they put three computer, so you copy the file to this computer, copy to this one, copy. Like that is not efficient. That is not manageable, right? That is going to take forever. So that's why the distributed systems are really important. Now I'm going to be a bit biased, and I'm going to lean it a bit towards data science because that's literally what I do. But distributed systems are widely used, like web development, servers, databases everywhere. Yeah, even blockchain. Yeah, some of the examples I'll give talk about blockchain. And I'm also going to talk about DAX. So I wish some of you never heard of DAX. But we use DAX where I work, and it's very efficient for Python data science. Docker, yeah, quite a number of you probably heard about Docker. Kubernetes, yeah. I mean, So I'm also going to talk about some benefits, issues in productions that I have noticed, and if there's time, take Q&A. So distributed systems are okay. Okay, so you literally have like computer programs, or you call them tasks, yeah, and you need to run them across multiple separate computational nodes. Now, these computational nodes talk about, okay, maybe you want to run them on various CPUs, or even GPUs or TPUs or whatever. Now, how do you run these things efficiently? Yeah, I'm sure some of you probably have tried using Google Colab GPUs, and then when you're looking at your usage, you're seeing maybe the RAM is high, the CPU is low, and you ask yourself, okay, how can I make my code efficient such that it can efficiently use these resources? So that is some of the things distributed systems force you to learn. Right? When you're running code on a simple computer, you don't really have to worry. I mean, just write the code, run it. Psh. But then if you're someone familiar with microservices architecture, you know that, okay, I have to refactor every single code and make it reusable, and the thing is, in distributed systems, this thing is very compulsory, because if you are distributing the same computer program across different CPUs, the code has to be efficient. Yeah, because if you're going to pass data, maybe you have a single set of programs, and you have the different data sets that you're passing through these ones. And if by any chance they need to communicate with each other, how do you write code such that these things are efficient and you don't run into problems? So these are some of the things distributed systems force you to learn. Right? And this definition, I got it from one Atlassian blog. So there are different types of distributed systems: client server. You have a client server. Probably some of you are familiar with that from web development. Peer to peer, like blockchain. I'm pretty sure probably most of us are familiar with blockchain, where you have like each node you have. It's just like a replica. Yeah. So something like that. Middleware, you have, okay, you can say you have the client, you have the server, and then you have like an application sort of being the middleman in between. You have three tier, where you have application, data, presentation, end tiers, up to as many as you need. Now, some things that are common with distributed systems are sharing resources, where you have two or three computers sharing the same resources in between them. Scalability, being able to scale as you need. Yeah, I'm also going to talk about some issues here. Being able to run multiple tasks right at the same time, detect errors, save time, and so on. Um, Now, if we don't have distributed systems, we have centralized systems, just like I said earlier, where you have like a computer running program. Yeah. Um, Now, a distributed system, I won't say all distributed systems use microservice like architecture, but yeah, that's literally what we do. We break it into components so that each computer can run these tasks efficiently, right? When you're not, for example, you're not having a dependency that like is shared in between these two computers, and then that causes errors. And then you also leverage parallel computing. You also, just like I said, need efficient and well refactored codes. And you can also turn your CPU to a virtual machine, just like the CPU you have on your computer, yeah, to make it look like as if you have infinite resources. So if you're really interested in like learning more about this, you probably want to learn about OS virtualization and all those things. Like it's really interesting. Um, so just to talk about DAX, Docker, the Kubernetes. Um, I want to start with Docker because Docker is what many of us are familiar with. Docker, containerization, you write your application, build it into an image, push to Docker Hub, woo, your application is live, right? Probably some of you have tried that out before. It's open source. It allows you to run your applications on virtual systems like Linux. Uses images. You have single applications that are built on simple containers. Now, the disadvantage with this is that you're just managing like one container. So, for example, if you're using like a microservice architecture where you have different containers for different applications, how do you sort of efficiently manage this, right? So with Docker, you can just use it on your laptop, right? Build an image, serve it. Maybe you build an API, push this to Docker, or you deploy on cloud, maybe AWS or Azure or any of that. Now, DAX is, like I said, a bias towards data science. DAX isn't the only one, yeah, but I use DAX, so I know it very well. Um, Allows you to run, for example, you want to run like multiple Python tasks, yeah, so you can just set it up. It's really easy. I didn't want to show the code because it's not tutorial, but then you can just check it out. Um, you can also turn your machine into like I said, a virtual house where you have supposedly infinite number of CPUs. Um, you can also use cloud backend like Kubernetes. And to get started, just pip install DAX. Yeah, and it's also open source, so you can see supports pandas, yeah, and it also supports some machine learning models like I think SVM and some other things. So it allows you to like use, you can call those models directly from DAX. And the essence of this is instead of you thinking about how can I write my code such that it's able to parallelize. So DAX has already done that for you. You just need to call it into your code. Another advantage of DAX is that it helps you manage your data. So for example, if you're handling large or big data and you need to send this into models and these models are running in parallel, how can you efficiently manage that data between you, the client, and DAX as the server? Yeah. So DAX already handles that for you with some models. Okay. Um, Now Kubernetes. Kubernetes, really interesting. I initially hated it. And sincerely, it's really difficult to set up. I remember when we wanted to like push our notebooks to production company where I was, it took us 4 weeks to set up, like to move from what we already have to the Kubernetes. I mean, this was the first time in my life I saw senior engineers. I saw all sort of engineers across the company sitting down in a meeting for 4+ hours, trying to figure out what is going on. What is like, I was just looking like, wow. To tell you that this thing, it can be really complex, very hard. Let me not say very hard, but hard to configure. But once you have it configured, very flexible to scale up, scale down, kind of stuff. Okay, so you can run it anywhere, hybrid on cloud, on premise, like whatever. So it allows you to scale resources based on demands. So for example, we initially started with running like a set of models, and what we needed was we needed 48 CPUs. We needed at least 30 gig memory. Yeah. So now we now realize that okay, we're going to push another set of models that needed less. So how can you scale right without breaking the bank? Because if you're not careful, you run into computing costs like so fast. So that's also one of the downside of things. So these things are like really expensive. You can't just be playing around. That's why I said as a beginner, you probably do not give you like production code because you just you run the company into loss. Okay, so yeah, so now the good thing is you can use DAX on Kubernetes. Yeah, so if you're looking at having maybe pushing to production or having production grade code, like what we do, um, DAX on Kubernetes allows you to leverage the power of DAX distributed system and also Kubernetes ability to manage multiple containers. So with DAX on Kubernetes, um, you can have so the Kubernetes is just like the backend that provides the resources you need, the number of CPUs, memory, all those kind of stuff. And DAX helps you do that distribution. Okay. Um, Yeah. So another good thing is, I'm sure probably some of you are familiar with YAML files, right? Yeah. So you can provision resources for every specific task you need. Yeah. So maybe for this task, I need about 128 gig of memory, 48 CPUs or 100 CPUs. And for another task, I need a lot less. So you can provision resources based on different tasks on individual configurations. Okay, so some of the um, benefits and trade-offs. So, of course, you can save time with efficient computing. Like, trust me, it's super fast. You just need to run Python something, do that in your terminal, and then you just let it run. And it can also improve system reliability and performance because If, for example, you're using AWS and maybe a node dies or just goes off, you have like backup. Okay. So, and that leads to the third benefit, which is fault tolerance. In systems where you're using you're having like redundant nodes. Yeah, so that redundance can serve as backup. So in case one node goes down. Um, Also allows you to scale horizontally and vertically. Horizontally means adding more CPUs. Yeah. Vertically means maybe adding more memory as you need. Okay. So some trade-off is that it can get very complex very easily, especially if you're not so like you're not so experienced with these things. Yeah. And where you have like so many nodes, you have so many clusters, and how do you efficiently manage this, especially when you're transiting or you're moving this to somebody who's just coming on the team. Yeah. And there was one problem that we had, which was with namespaces. It took us 2 weeks, really. I mean, 2 weeks with top engineers in the company to literally figure out how do we create reliable, efficient namespaces where which are like um, which doesn't cause conflict. So we already have like an existing cluster, and then we wanted to create another separate like node space. So we have one for production, one for development, one for testing, and that caused like a lot of conflict. Another issue you can have here is with the provider itself. So there was a time that we scaled the system to have like more resources, and then AWS just so some of the resources we need were not available when we needed them. So that sort of broke down production, right? Because we're asking you run and then take this required amount of resources, but then they were not available. So what we had to do was we had to upgrade. So these are some of the issues you get. So if you're using a cloud, yeah, you need to be able to like sort of have that in mind that sometimes when you need these resources, they are actually not available. And that's why it's good to have like multiple resources in multiple regions. Um, Another thing is data consistency. For example, if you're having maybe you have your own on-premise distributed system, some issues you run into is with data consistency, right? Network and communication failure, communication between each of these nodes, and also your replication strategy, right? So you may not really run into these issues if you're using cloud-based systems, but if you're having like on-premise based systems, yeah, or you have like hybrid, that's when you really run into these issues. And some of the things that you use distributed computing for, right? Data science, running multiple models. Also use the weather modeling, um, complex computation, simulations, and all the kind of stuff. Okay. Um, yeah, just like I mentioned before, some issues in production is that resources can become limited, right? So you need to be aware, and then as you upgrade, like of course, with more upgrade costs more cost. So maybe something you have to pay for, maybe you pay like $5 for now because the resources can become limited. You have to pay like $8 for, I mean, maybe per hour or per minute or whatever. So costs can grow very quickly, and that's why you need experts on this. So this is not for testing, right? It's not for beginners to just go and test around because yeah, you can keep up bills. And another thing is poor configuration. So if your files are not well configured to manage scalability, right? Let me give you an instance. So for example, where you're provisioning maybe you're provisioning memory and CPUs, yeah, in your YAML files. And if you don't have a good structure, yeah, so maybe in a file here, you say, okay, maybe for DAX cluster, you have this, and then you have another file that sort of manages the whole nodes. And then there's some sort of conflict. So because you have like these things specified in multiple files, if you change one, you can literally break the whole stuff. So that's why you need to have very good configuration, know how to like configure multiple files. So if there's poor configuration, it can lead to scaling problems, and these things are quite difficult to detect. So finding where exactly this is coming from can be difficult, especially if you don't have a great login system. Yes, that's another thing. So if you don't have excellent login system, it's be really difficult to figure out where the problem is coming from. Okay, and that is the end of my session. I hope you learned one or two things. You have questions?
Questions, questions. Hello.
Thanks for the talk. So the question I have is around, you mentioned login system. Any recommendation on um, the login setup for distributed systems like maybe Docker or Kubernetes?
I don't I can't say there's like a go-to because I think it depends on your company. So I don't know the size of your company and I don't know the number of developers or how many people are using it and what it is for. So my company is like um Coachava, yeah, one of the biggest advertising firms in the US. So because of the kind of clients we serve, right? We have like sort of a big system, sort of, yeah. So now, because we also have like many other applications, so we're not the only ones using Kubernetes, right? Other teams are also using the same Kubernetes that we use.
Okay.
So because of that, the login system isn't just limited to my team,
All right.
right? So you have like other teams also like part of it.
All right.
So I can't really say, okay, this is the best way, but then you probably need someone really experienced in architecture, yeah, so that they can figure out. It's not. I won't really say it's a matter of two. It's not really a matter of two. It's a matter of who really understand how these things work,
Okay.
right, and then can determine, okay, maybe this is what you use. I mean, there's so many login tools. Yeah, I've tried a lot, but that wasn't really the problem. The problem was understanding how can we manage all these systems and then integrate the right login tools.
All right. Thank you.
Any more questions? Seems like a very interesting topic.
Hi, I want to ask, how do we manage environment variables within these distributed systems?
Okay, I think that's more code, not really about distributed systems. Um, what we do is that this environment variables resides on the system itself. So when we distribute code, you are not distributing the environment; you just load it. So you're not distributing environment variable to each and every node. No, it's already. For example, you can say, okay, it's on the server already, right? And then you just distribute the code. So you're not distributing the environment variables; they reside on the server itself.
Any more questions? Very much.
Thank you.
Please a round of applause for her.